Okay. So 3E we are talking about kinematic, huh? Okay. For kinematic, if you look at the example one that I give you, you have the example one. So I'm going to explain all the concept about kinematic using the example one that I give. So example 2 is the one that you have to go back and do it by yourself. So example 1, they will say, an object is traveling along a straight line. So if those who are study physics, you are talking about object travel in different direction. So this one we are talking about on a straight line. So the straight line can be vertical, can be horizontal, can be slanting. One direction only. Okay. Okay, so the question will give you, okay, they say, such that it position. So, and they give you ST. That is 2t cubed plus 3t squared minus 36t plus 18 cm. Okay, so now I want to explain in kinematic. This is called displacement. Okay, what do you mean by displacement here? So we are talking about object moving on a straight line. So this is the straight line. So this is your S. So there is a fixed point on this straight line. We call this origin. Okay. So when I say displacement, that means how far is the object from the fixed point? That is called displacement. It can be to the left, it can be to the right of the origin. So ST show you the displacement. And in another word, if you look at the example, means the position of the object at any time. If the question asks for position at any time, so you have to go to the ST function. You get me? Like for example, I'm waiting. I'm emitting someone. Okay, like for example, okay, so now all kinematic, you are dealing with time. In physics or in maths, time is a scalar quantity. So the domain for this case will be T. T is a member of real number, and T must be greater than or equal to 0 because T is a scalar quantity. Any scalar quantity, the value will be 0 or more. in max, we have a negative quantity. Negative value is for those vector quantity. Positive represent one direction, negative represent the opposite direction. So that is about, in this, you have to know a scalar and a vector quantity. Displacement is a vector quantity. Okay, so it has magnitude and direction. So now, so if the question asks for position, you put what? You look for the function st, displacement function. Okay, now if the question say find the initial position so what does the word initial tell you? So very important. So very first, so what? Yes, initial straight away say when t equal to 0. What is your S0? That is called initial position. The moment in kinematic you see the word initial means you have to substitute t equal to 0. Got it? So the initial position will be 18 cm. Am I right? So how do I interpret 18 cm? So where is the object initially when I want to study its motion? It is 18 cm what? From the origin, it can be left or right. 18 cm on the right or at the right? Should put on or at? To the right. Okay. This is English. To the right of the origin. If you don't want to use origin, you can say fixed point. So that means I start to study the motion of the particle when the particle is here. Before that, where is it? I don't care. Are you clear? So that is talking about initial position. So if the question asks for position, what you do? Okay. But if you go to the first part of the question, can someone read to me the first part of the question? Yeah. So they want you to find the velocity function and the acceleration function. So those physics students, can you tell me what is the relationship between displacement and acceleration? Definition. You lose to me. What is, how do you define velocity? Definition of velocity.
Derivative of displacement.
You tell me derivative of displacement, I disagree lah. I want definition. If you do like that for physics, you fail straight away. Velocity is the rate of change of displacement. So velocity is the rate of change of displacement. So if I want to find the velocity function, what should I do with the displacement function? Yeah, dy dx. Where got y? Hello. So how should I write mathematically? So everyone, please start to do. If I want to get velocity function, I must find s prime t. There's a notation, am I right? Rate of change of displacement. Okay, now everyone differentiate. Okay, are you done? Okay, so I get 6t squared plus 60 minus 36. So cm per second. Okay, so if I want to draw the sine diagram of VT, what should I do? You want to draw the sine diagram for any function, what should you do? You got the function already. Next, what must you do? You must find the time when velocity equal to 0 so that you can mark on the line. Am I right? So now can you please do so? You can use your GC, you can use your manually. Hurry up, do it now. Can someone mute yourself? Can you please do it now? So first of all, I want to draw the sine diagram. I must know Vt equal to 0. Okay, so you can use your scientific calculator or your graphic calculator to get the answer. Yep. So I have t minus, this is 6. Correct? So t equal to -3, not the answer. Why? Because t must be greater than 0. So t equal to 2. Correct? Okay, so now, how do you interpret? So before we go to the sine diagram, how do you interpret Vt equal to 0? What does that mean? If I say velocity equal to 0, what does that mean? That means the displacement is stationary, correct? So if the displacement is stationary, means the particle is not moving. So that means this is also give me the sense of stop. The particle stop moving. If I ask you to find when the particle stop moving, that means Vt equal to 0. You are not moving. Your velocity is 0 means you are not moving, correct? So your displacement equal to 0. Stationary. Hello? So if I ask the question, find the time when the particle stop moving. So what should I start? I start with Vt equal to 0. Clear? Okay. Shin Lee, can you please mute yourself? Okay, so now I want to draw the sine diagram for Vt, correct? Domain very important, am I right? So what number must I mark on the line? 2. So how can I determine the sign? I got my graphic calculator, correct? Please go to your graphic calculator and determine the sign. So you should key this in your Y1. So you call out your Y2. What is your answer? Negative. For t greater than 2, positive. Anyone got any issue with that? Those online, are you okay?
Yep.
Yeah, I hope those online not sleeping. Huh? Okay, so all good. Yes, okay. Thank you. Okay, so now, how do you interpret negative sign for the velocity and positive sign for the velocity? What does velocity tell you about the motion of the particle? Yes, thank you. Velocity, sign of velocity give you the direction. If Vt is less than 0, means negative sign. This implies just now our direction, right and left. The object is moving to the left. Okay, if velocity is equal to 0, object stop moving. If velocity is greater than 0, yeah, object moving to the right. Are you clear? So now I want to let you see the motion of the object on the straight line based on this sign diagram. This is not part of the answer. I'm just because I want to explain everything. Okay, now you look. Just now we have the object, right? This is a straight line, this is the origin. The object is here, 18 cm. Do you know in which direction it moves? You don't know. So what must you do in order to know how the direction of motion at the beginning? So I have to find the initial velocity. Am I right? Can you look for initial velocity? How to find initial velocity? Yeah, V0. That is initial velocity. Can you tell me what is the initial velocity? Negative 36 cm per second. Am I right? Everything 0 here. Okay, negative 36 cm. How are we going to talk about the motion of the particle based on this value? The particle is moving to the left with the speed of 36 cm per second. The word left represented by the word, the sign negative. To the left with the speed of 36 cm per second. You see or not? So, okay, correct? So you look at here, that means if I draw a car, that means it starts from here. It moves like that. Am I right? Yeah. So it move to the left until when it starts to turn to the right. So do I know where it stopped? Do I know where it stopped? Where? Where? Not when. I'm talking about where. If I want to know where it stopped, what should I do? You see? Stop at the origin. No. I'm asking where. Where it stops. I'm talking about where means I'm looking for position. You better get it right. When is time. Where? Position. Direction? Velocity. See or not? So I know when it stopped, but I don't know where it stopped. So how to do? You look for S2. So if you key all this into your calculator, can you find S2 easily? Yes. Tell me the answer now. Negative 26. So you better have your calculator with you. Negative 26 cm. That means the particle will move from here until here. Negative 26 here. Then it stops. Stop doesn't mean it will turn. Stop doesn't mean it will make U-turn. I can stop and continue. If it stop and continue, then the sign on the velocity sign diagram will not change. Am I right? So bear in mind, stop doesn't mean it will turn. But if you want to turn, it must stop. Every time when your car make a U-turn, correct? Do you know there is one point where it must stop? Then only you can change direction. Hello? Do you get me? So now, here the sign become positive. That means it stop, then it turn, make a U-turn. Then it never turn again because there is no time. After t equal to 2 is stop, it never stop again. So it will continue forever until where I don't know. What question are you asking? That's why very troublesome now. What means out of curiosity, since negative is left and positive is right for velocity, is there an up and down? Definitely. Up is positive, down is negative, as simple as that. That's why you learn negative number in maths. Correct? Up is positive, down is negative. Don't study econ. Price up, positive. Price down, negative. Am I right? You play share, I play share. I play share, earn more than my pay. No, I don't play. I don't play share. High risk, high gain. I'm a person, no risk, no gain. I cannot go that kind of risk. My heart will, cannot. I see the share price up and down, correct? My heartbeat also go up and down. So that is how it go. You see or not? Got it? So you get all this right. So why you need to draw the sign diagram of velocity? Because you want to know the direction of motion of the particle, and you also want to know when the particle stop moving. When the particle change its direction of motion. I told you already, stop doesn't mean it will change. How I know it will change direction? If I look at the sign on the sign diagram of VT. Any issue before I go further? So I try to give you all the understanding of how to interpret the sign diagram first. Got it? Done. So if the question asks when the particle changes direction of motion, what must you do first? You must find the velocity equal to 0 first, find the time, then you draw the sign diagram. Then you see when it changes the direction. Bear in mind, stop is a must before you can change the direction. But if you stop, doesn't mean it will change the direction. Like for example, I drive all the way back to Malacca every fortnight. Understand the meaning? Fortnightly. Once every 2 weeks. Let's go fortnight. Okay, so I will stop by at the station. Okay, one of the rest place. Then I will continue to move in the same direction. All right, that is called stop. Doesn't mean you will change direction. But if you want to change direction, you must stop first. Okay, got it? So we are done with velocity. Try to give you all the understanding. Yes? Okay, any issue? Before I go to the next one? Then the rest of it, you can answer for yourself already. I don't have to teach already. Okay, now. So the next part of part A, part 1, they want you to do the acceleration sign diagram, correct? Am I right? So now, can you tell me definition of acceleration? So this all physics student, very good. Acceleration is the rate of change of velocity. Okay, so acceleration, we use A to represent, is V prime T. So that means, can I say is S double prime T? Yes, because velocity is S prime T. Rate of change of velocity. Okay, so just now our velocity is 60 squared plus 60 minus 36, correct? So acceleration will be 12t plus 6. Am I right? You differentiate this. So now, if you look at this, t is greater than or equal to 0. What can you say about the acceleration? So 12t will be greater than or equal to 0. So acceleration, which is 12t plus 6, will always be greater than 0. Am I right? So is there a time whereby the acceleration will be equal to 0 for this case? No. So therefore, my sign diagram. That's it. That means the particle is always accelerating. What do you mean by always accelerating? That means the velocity is always increasing. You agree with me? You agree with me that the acceleration is always increasing? And the velocity is always increasing? Just now I give you the motion diagram, correct? This is 18. I start to study the motion of the particle. Then the particle move until here. There is negative 26. The particle stop. Then after that, it changes direction, correct? The velocity at this case is negative 36 cm per second. The velocity at this situation is 0. Then after that, it goes positive, correct? From t equal to 0 to t equal to 2. The velocity changes from negative 36 to 0. Am I right? Am I right? So velocity is increasing. From negative 36, you go to negative 30, isn't it increase? From negative 36, you go to negative 30, isn't it go up? Okay, but you look, but the speed go from 36 to 0. So can you tell me speed is increasing or decreasing? Decreasing. For this situation. So now, if I want to know the changes of the speed, I must have both velocity sign diagram and acceleration sign diagram draw on top of each other. So this is a way to determine changes of speed. So acceleration is always positive, correct? So look, this region. Opposite sign for both. Opposite sign means one negative, one positive, or one positive, one negative. That's called opposite sign. Show decreasing speed. Are you clear? Same sign for both show increasing speed. So if you want to determine whether the speed is increasing or decreasing, you must have which two sign diagram? Both acceleration and velocity. I show it to you already. That will help you to judge about speed. Are you clear? So these are the skills that you must have when you talk about motion in the straight line. Clear? So I finished teaching the whole thing. I only left with one part. Okay, so shall we go to that question and answer each part by part? You have that question? So part one we have done. So the answer for part one, I don't care how you get the answer, as long as in your SAT2, very first question I will ask this. I can give you the question now, but I give you different function, okay? So to answer this question, so part one, so I will use the ST, then I will, okay. So you see how I do, I present my answer. Or just how that one is explanation, okay? Okay, so I will put VT equal to 60 squared plus 60 minus 36. Okay, you must put the unit of measurement. No unit of measurement is up to me, want to deduct your mark or not. Depend on my mood when I mark your paper. That is not true, okay?
Teacher,
Yes,
then your ST also must write CM, right?
that one is given by the question, this is not part of my answer, so I want to write the one to write my choice.
Okay.
Am I right? Okay, so after that, I got this already, then I draw the sign diagram. How I get the two, I don't have to tell the examiner. You can get it from the graph, you can get it from the calculator, you can get it well, whatever you use. Then this is a negative, this is a positive. Then my AT sign diagram, always positive. You want to write how many positive, up to you. You write one also nothing wrong. Okay, so how I mark? 1 mark. So this part will carry 4 marks. Anything wrong with the thing, 1 mark gone, that's it. So how you want to do your working at Takesa? You see or not? Okay. Then for part 2, initial position. So I just put S0 equal to, I use my graphic calculator to get the answer, 18 cm. So if they ask you to interpret, so I have to say initially 1L or 2L? 2L, 1L or 2L? 2L. Initially, the object is 18 cm to the right of the origin or fixed point. So I done with my, and this is also 1 mark only. Satu markah saja. Okay. Then for part 3, A, find the initial velocity. So same thing, V0. You go to your Y2, you get the answer. Yeah. So you get negative 26 or 36. 36 you jangan menakutkan saya. So how you interpret? Initially, the object is moving or traveling up to you, is moving to the left with the speed of, you don't say the velocity already, because I have said the direction already, speed of 36 cm per second. Done. How many marks given to you? Also 1 mark. Okay, then part B. What is part B? The velocity of the object when t equal to 4 seconds. So what you need to do? V4. Can you tell me the answer? You didn't key in. Do you know maths teacher never calculate one? Maths teacher calculate, the student won't be clever. Yes? What is V4? 84. Wow. 84 cm per second. So how do you interpret this? At t equal to 4, the object is moving to the right with the speed of 84 cm per second. Okay, done. You see how easy can we get the mark? Another 1 mark. Okay, so we are done with part B. Part 3. Okay, part 4. What is part 4? Find the time and the position when the object reverse direction. So this is a key word. Reverse direction. Mean turn. If want to turn, it must stop. So stop means Vt equal to 0. So I say from A. Do I need to calculate again? No need. I will say from A, t equal to 2. Correct? So then I look for position S2. What do you get? Negative 26 cm. Done. And you get 2 marks. Okay. So number 5. You see, so easy. Find the time when the object speed is increasing. I told you already, you want to talk about speed increasing, you look at both of these from part A, correct? So speed increasing, Vt and At must have the same sign. So that is the thing that you must have. So from part A, you choose this region. Am I right? So therefore, T must be greater than 2. Am I right? So 1 mark. Same sign, both positive or both negative. It doesn't matter. Yeah. Okay, done with that. Number 5. Done. Show that the velocity is always increasing. I told you how to show. You show that At is always positive. Correct? So number 6. At is equal to 12t plus 6. So t greater than or equal to 0. So 12t plus 6 will be greater than or equal to 0. So shown. Done. Hello? So now, find number 7 should be no problem. So I'm going to complete part 8. Find the acceleration when t equal to 6. Okay, let me complete part 7. I'll give you a complete answer. Okay, can I move? So part 7, A7. So that means it's 12 times 7 plus 6. 7, 84, 84, 90. Am I right? 90. 6 啊，6 62 72 72 72 78 78 78 78. I can't count in English, okay? I can't count in English. Don't ask me to count in English, it kill me. I count very slowly in English. Okay, so that is number 7. Okay, number 8. Okay, find the total distance traveled by the object in the first 3 seconds. So I'm going to do this problem by drawing motion diagram. So every time when I want to find total distance traveled, I will draw motion diagram. So motion diagram means just now the diagram that I show how the particle move. Okay, so the time frame that I have is from first 3 seconds means like that. This is the meaning of first 3 seconds. Clear? Okay, first 3 seconds. Okay, now start. T equal to 0. S0 is S0 is 18. Does the particle stop within this time? No. The particle doesn't stop. Am I right? So within this period of time, it stop moving or not? Between 0 and 3 seconds, it doesn't stop moving. Yes, it does. So you have to get the stopping position. That is negative 26 cm. Am I right? So final. Can you give me this answer? So this is a question that you have to ask. Negative 9. Okay, negative 9 cm. So now I want to start to draw the motion diagram. I'm here, 18. Then move zoom, until here, negative 26. Then turn until here. All right. And here is negative 9. So you tell me, hey, who is that one? Hey, Dixon, what are you doing? Playing with my screen. No one is supposed to touch my screen. Can you tell me how far has it moved? Accident. Accident can kill people, one, no? Okay, how far is this distance? 18 go to negative 26. Can I say this is 18 plus 26? Okay, how far is this distance? 17. 26 minus 9. Correct? So therefore, total distance traveled you look at the motion diagram, then you find the answer. 18 plus 26 plus 26 minus 9. It's up to you how you want to count. So the answer is 61. So this is called motion diagram. This is called motion diagram. Everyone must learn how to draw. Because in the exam, I can ask you to draw the motion diagram and find the total distance traveled.
Teacher,
Yes?
total displacement is just 26 plus 18, right?
There is no such thing as total displacement. Only total distance traveled. I will say, what is the displacement after 3 seconds? I will not ask total displacement. There is no such question of total displacement. Understand? Because
yes.
the displacement is from the initial point to the final point. So I will say, what is the displacement after 3 seconds? I will not ask total displacement. I only will ask total distance traveled. Clear?
Yes.
Okay. So there will be one question of kinematic like that. Got it? Can I put it in such a way? Okay, if talk about application, can I put it in such a way that find the time when the displacement is decreasing at the fastest rate? Can I? Can. That means you have to find the inflection. That means you have to find that the acceleration equal to 0. Ha ha. You see now, you see how I apply it? Can I ask, find the time when the velocity, when the displacement is decreasing or increasing at the fastest rate? Because acceleration is f double prime x. Yes. Yeah, depend on the function I give you. For this function, there is no. Acceleration never becomes 0. So where got displacement decrease at the fastest rate? Or increase at the fastest rate? At the beginning? Maybe at the beginning, I don't know. Yeah, it never. Okay, can or not? Okay, so example 2 is your task. And exercise 3E is your task. So you go back and try. You have tomorrow to ask me about kinematic. Then Monday, I'm going to talk about rate of change. Okay. Then Wednesday, I'm going to talk about optimization. Yeah. Then after that, you go back, you have the whole holiday to go through your everything. So you don't tell me you have no time to do. I purposely plan it in such a way that you got the break to complete your work. Thank you, class. Okay, thank you. You may go.
Thanks.